Welcome back. This is an Aleks training video on calculating partial pressure in a gas mixture. We've already looked at the mole fraction, and we're going to use the mole fraction again. In fact, it's just one more step to do partial pressure. So as we did before, we're going to start with the amount of grams that they give. So we have 9.38 grams of the dinitrogen difluoride. And I already looked up the molar mass from the periodic table, and it is, for two N's and two F's, 66.0102 grams in every mole. And when you divide that out, you get 0.142099251 moles of N2F2. Now we're going to do it again with the boron trifluoride, and they give you 6.03 grams of boron trifluoride. Its molar mass from the periodic table is 67.806 per mole. So when you divide those numbers, you get 0.088930183 moles of BF3. Okay, so those two moles added together will be your bottom number on your, like the bottom number of your fraction. So when I add these two together, 0.142099251 plus 0.088930183, I'm going to get 0.231029434. Let's do that twice. 0.231029434. So you're going to take the first one, goes here, the second one here. Okay, so the first one is the N2F2, and when you do 1.142099251, okay, divided by 0.231029434, I get 0.615069, and then over here 0.80889300183 divided by 0.231029434 gives you 0.384930009. Okay. So I look first of all at the number of significant digits. I've got 4, I've got 3, I've got 3, I've got 3. So I need to do it to 3. So I've got 0.615 and 0.385. Okay. All right, so the mole fraction of the dinitrogen fluoride we just found was 0.615. The mole fraction of the boron trifluoride was 0.385. Okay. All right, so let's get some more room here. I need to now find the pressure. So I'm going to use the combined gas law, or the ideal gas law. PV equals nRT. And then I'm going to fill in what I have been given. So it says, first of all, we've got a 10-liter tank. So it's going to be 10 liters. I have my moles, which is this bottom number, 231029434. Okay. The total pressure, I assume, is in atmospheres. Since it's in atmospheres, this number here is going to be 0.820574. And my temperature is 0.694, it says 0.694, and then I have to turn it into Kelvin. I had 273 plus 273.15, and that's going to give you 273.844. Okay, so you can see I've got, this is the only unknown. I've got all the rest of them are known, so I'm going to divide by 10. So I'm going to have P equals all of that, so N times R times T divided by 10. 273.844 times 0.08200574 times 0.231029434 equals, divided by 10 equals, and I get the total pressure as 0.519144546 atmospheres. Okay, so I need to round to 3 significant digits just like I did the other. So it will be 0.519. So this would be 0.519 atmospheres. And then I'm going to take the 0.519 and multiply it by these two mole fractions. And that's the partial pressure. The 0.615 is 61.5% of the total pressure, and the other is 38.5% of the total pressure, and that's the partial pressure. So when I take 0.615 times 0.519, I get a total of 0.319 atmospheres. Now this is in atmospheres because it's actually pressure. And when I take the 0.385 times 0.519, okay, it rounds up to 3 significant digits. I get 0.200 atmospheres. So really cool question. I really like this. There's a lot of parts to it, but they're not hard. Just think slowly.